Hi everyone, in this video we are going to be talking about inequalities. So first off, before we get into actually solving some inequalities, we're going to talk about interval notation. So what does x is greater than 4 actually mean? So if we take a number line and we say that 4 is, say, right here, we don't need to actually put all of the numbers on the number line because all we really care about is 4 right now. Right? So x is greater than 4 means x should be bigger than 4. Where are the numbers that are bigger than 4? They're on the right side. So all of these numbers are bigger than 4. Okay, now at 4, can x equal 4? No, because we said x has to be greater than 4. That means it can't be 4 because 4 isn't greater than 4. It's equal to 4. So all we're going to do is put a parentheses, and I'll explain that more in a second. And this arrow at the end means that it doesn't stop because, say right here is 10. Yeah, 10 is greater than 4. Say somewhere out here is 20. 20 is bigger than 4. But so is a million, a billion. Numbers so big that you can't even think of them. Those are all definitely bigger than 4, right? So this arrow just means infinity. So interval notation, all that does is we're going to write this a little more compactly. We are going to say that it's from 4 to infinity, and then we give it parentheses on both sides. Okay, so those parentheses just mean that it's not included. All right? So we said that we didn't want 4, so we put parentheses on it. We're always going to use parentheses for less than or greater than. Right? If we do want it included, which will be whenever we have less than or equal to or greater than or equal to, then we're going to use brackets. A bracket means that it can be, or is rather, included in the interval. Right? Now for parentheses though, we are also going to give those to infinity because we can never really reach infinity. So we're just always going to use parentheses anytime we put in infinity. All right, so with that said, for these, we're going to start by putting some graphs and then putting them in interval notation. All right, so for the first one, we make a little number line. This time we have 7 on it. X is less than or equal to 7. So this time, less than or equal to means that we want stuff less than 7. So that'd be on the left. Right? And by the way, one little hint. If your x is on the left side of the inequality symbol, then if you think of the symbol as like a little arrow, it actually points to the direction that you would need to shade. This one's pointing to the left, so we shade to the left. All right, what about at 7? Well, this time we had less than or equal to, so we want a bracket. So to write it in interval notation, we're going to write it as negative infinity this time, because this is going towards the negative numbers. So negative infinity to 7. Any infinity always gets parentheses, and we already said our 7 gets a bracket. All right, next one. X is greater than negative 6. So here's negative 6. X is greater than negative 6, so that means we're going to be shading the stuff that's greater, which is going to be to the right. It's not or equal to, So we're going to put a parentheses at -6. And this is going out to positive infinity. Again, just read this left to right now. So from left to right, we have -6 with a parentheses all the way to infinity, and infinity always gets parentheses. All right, next one's a little trickier. So this time it has two different numbers. All right, so it says -2 is less than x, which is less than 5. So this time we're going to go ahead and put both of those numbers, -2 and 5, on our number line. All right, now as long as they both have less than like that, or it could be less than or equal to, or any combination of those, then all you have to remember is if x is in the middle, we're going to shade in the middle. That's where x is bigger than -2 and smaller than 5. That's what that inequality really means. Now both of those were just less than, which means both of those are going to get parentheses. So in this case, our interval notation isn't actually going to have any type of infinity. We're just going to read off those numbers. So it's from -2 to 5, both with parentheses. Next one, it's going to be very similar. It's even the same numbers. The only thing that's changed is now they are both less than or equal to. So we're going to start the same way. -2 and 5 are going to go on our number line. X is in the middle, so we shade in the middle. So this time, since they are both less than or equal to, we are going to be putting brackets on both. So our interval notation will be -2 to 5 with those brackets. All right, example 5. Again, still same exact idea, still very similar. So draw our number line. We're going to put both of our numbers on there. In this case, it's -4 and -1. X is in the middle, so we shade in the middle. Only this time we have to be careful with those inequality symbols. So -4 is less than x. That means -4 gets a parentheses. And x is less than or equal to -1. So that means that one gets a bracket. So we are going to have -4 with parentheses to -1 with a bracket. All right, go ahead and try number 6 real quick. I'll give you a couple seconds. Pause the video if you need more time. All right, we are going to go ahead and show you the answer now. Still -4 to -1, just the -4 has a bracket now, and the -1 has parentheses. Okay. Just to make sure that everything's clear, let's go ahead and go in the opposite direction now. All right, so you're given the interval notation. We're going to see if we can go backwards and figure out the inequality from it. All right, so these first 3 from this section both have numbers. Right? Since they both have numbers, that means it's going to look like these. It's going to have x sandwiched in the middle. All right, so first off, let's go ahead and draw a graph. So for example 7, we have 1 and 6. And it's that region in between them with a parentheses and a bracket. Okay, so remember, this means that x was sandwiched in between those two numbers. So we got 1x and 6. for the inequality symbols, we just need to figure out if they were using parentheses or bracket. For the one they were using a parentheses, that means it's just less than. For the 6 they were using a bracket, which means it's less than or equal to. All right, let's try another one. So for example 8, we have -5 and 2. Again, it's this interval in between with a bracket on the -5 and a parentheses on the 2. So again, same as before, we have -5, x, and 2. All we gotta do is look at the brackets and parentheses to be able to tell what those symbols were in between them. So the -5 has a bracket. That means it was less than or equal to. The 2 had a parentheses, which means it was less than. All right, again, go ahead and try number 9. It's very similar to 7 and 8. I'll give you a few seconds. All right, pause the video if you need more time. Otherwise, here is the answer. It should be -3 is less than or equal to x, which is less than or equal to 1. All right, moving on to number 10. So number 10 does have an infinity this time. So it's not going to be one of those where x is sandwiched in the middle. So let's go ahead and do the graph and see what this is going to look like. So we have 2, and it says it goes from 2 to positive infinity out to the right, with a parentheses on the 2. All right, so we know we have an x, we know we have a 2. In this case, we want x to be bigger than the 2 because it's off to the right. That's where the bigger numbers are. So if we want x to be greater than 2, then we're going to put greater than 2. And that's all there is to it. We're not putting greater than or equal to just because there's no bracket. It's just a parentheses. Number 11 is going to be the same exact idea. So if we do one more of these little graphs, we got 3 on here, and in this case, it actually says that it goes from -infinity to 3. All right, so -infinity is off to the left, and it also shows it as a bracket on the 3. All right, so again, I know I need an x, I know I need a 3. This time, since it's going off to the left, that means x is less than 3, because we know we want it going to the left. But also we have a bracket this time. So that means not only we're going to put less than, but we're going to put less than or equal to, and that covers the bracket. Okay, so what is all of this going to be used for? This is going to be how we write our answers to linear inequalities. So that's going to be our next thing. We're going to be solving linear inequalities. Now, solving linear inequalities is very, very similar to whenever we were solving linear equalities. The only difference is now we're having less than or equal to or greater than or equal to. That's going to be in the equation, or sorry, inequality rather. So that's going to change a couple things. One, we're going to write our answers in interval notation. So that's why we learned interval notation. But 2. So if we look at this right here, -2 is less than 6. That makes sense, right? Because -2 is definitely less than 6. All right, remember, we can always multiply equations on both sides by the same number, right? So if we multiplied or divided, it doesn't matter, both of these by -1, then we would have 2 is less than -6. That's no longer true though, because positive 2 is bigger than any negative number, right? Right, so this is the one thing that you need to remember, and definitely star this. Anytime you multiply or divide by a negative, the inequality has to flip in order for it to stay true. So in this case, since we multiplied by a negative, it would become 2 is greater than -6. That would still be true. Right? So that's the one thing that we have to watch out for. Otherwise, we're just going to be solving this like it's a normal equation. All right. So if we look at number 1. So for number 1, we have 4x minus 3 is greater than -23. So first thing we want to do is move that constant. So we can add 3 to both sides. Get 4x is greater than -20. Then we have 4x, so we want to get rid of the 4, so we divide both sides by 4. And we get x is greater than -5. Notice I did not flip the inequality, because even though we ended up with a negative answer, the number I actually divided by was +4. We're only going to flip it if we divide by a negative. Okay, so we got this. Now we're just going to go ahead and write it in interval notation. So -5 is right here. It would be shaded off to the right, and it would have a parentheses. So it'd be -5 to positive infinity, both with parentheses. All right, let's try example 2. So for example 2, we have x on both sides, so we're going to start out by moving those to one side. Now, personally, for inequalities, I always just like keeping x on the left, because if x is on the left, then whenever we're graphing it at the end to put it in interval notation, we can just shade in the direction that the arrow points. All right, so I'm going to move the 7x over by subtracting 7x, just so we can have it on the left at the end, but you will get to the exact same place no matter what. So if you moved it to the right, no big deal, you should still get to the same answer. So we're going to have -4x plus 1 is greater than -15. We can subtract 1 from both sides. So we get -4x is greater than -16. And then we're going to divide both sides by -4. But remember, this time we are dividing by a negative. So this time we are going to need to flip that inequality. So we're going to have x is less than +4. Again, last step, if we want to just put it in interval notation, we have 4. It's going to be shaded to the left towards -infinity. And it's going to have a parentheses. So -infinity to 4, both with parentheses, is our answer. All right, back to the thing that everybody loves the most in the world, fractions. So in this case, we're going to start off by using the LCD to go ahead and clear those fractions. All right. In this case, the LCD is 6, because 6 can be divided by 2, 3, and 6. So we're going to multiply every single one of these fractions by 6. All right, for the first one, 6 divided by 2 is 3. And I'm going to go ahead and just write that and bring that x minus 4 down, just so you can really see the next step that's going to happen when we have to distribute it. Greater than or equal to 6 divided by 3 is 2. Again, I'm going to go and bring that 2 down because then we'd multiply by the top, but I want to make sure that everybody sees that we're about to distribute. Last one's easy. 6 divided by 6 cancels, just plus 5. No more fractions, so everybody's happy. So now we're going to start simplifying. So we can distribute the 3. So we got 3x minus 12 is greater than or equal to, distribute the 2. So it's going to be 2x minus 4, then plus 5. Negative 4 and positive 5 can be added together. So we got 3x minus 12 is greater than or equal to 2x plus 1. Okay, we want to get x on one side now. So subtract 2x. We got x minus 12 is greater than or equal to 1. And luckily only one more step. Add 12 and we get x is greater than or equal to 13. So here's 13. We would be shading to the right, and it would have a bracket on it. So our final answer is going to be 13 to infinity. All right, next one. Again, first step, we want to go ahead and distribute. So we got negative 3x minus 6 is greater than 2x minus 11. Bring x's to one side. Again, I like bringing the x's to the left. So I'm going to subtract 2x from both sides. We'll get negative 5x minus 6 is greater than negative 11. Move the constant over. So add 6 to both sides. Get negative 5x is greater than negative, oops, not negative 6, negative 5. Divide both sides by negative 5. And again, we just said divide by a negative. So that means we are going to go ahead and flip the inequality, so it's now going to be less than 1. Write that in interval notation. We have 1 right here. It's going to be shaded to the left. So that is going to be negative infinity to 1. And oops, I forgot the parentheses. But they will both have parentheses on them. All right, last one of these. Again, this has a fraction in it. So first thing I would do, just so we can keep everything nice and simple and consistent, multiply everything by the LCD. If there's only one fraction, then just that number on bottom is going to be the LCD. So multiply everything by 2. 2 times 1 is 2, minus 2 divided by 2 cancels out, so we got that x left is greater than 8. We can subtract 2 from both sides to get rid of the constant. And divide both sides by negative 1 to get rid of that negative, because remember, we don't want negative x, we just want x. And since we divided by a negative, we're going to flip it. It's going to be x is less than negative 6. So here's negative 6. It's going to be everything to the left of it with a parentheses. So negative infinity to negative 6. All right, last few. Sorry, I know this video is getting long, but we are on the last 4 now. So now we are going to be talking about compound inequalities. So compound inequalities are really 2 different inequalities that are put together. And they're the ones that we've already done graphs for. It was when x was sandwiched in the middle. We're just going to be solving them now as well, though. All right, so for example 1, the first thing that you probably want to do, at least until you get used to it, is don't look at this section. Don't actually mark this out on your paper, because you are going to need that number in a second. I'm going to bring it back. But if we don't look at that, then this looks just like a normal inequality like we were just doing. What would we do? We would subtract 3 from both sides. Here's the difference. If we look at that 1 is less than or equal to again, that's like a third side of our inequality. So whenever we used to do stuff to both sides, we're now just going to do stuff to all 3 sides. So 1 minus 3 is negative 2. It's less than or equal to 2x is less than 8. All right, again, just for a second, don't look at the negative 2. Just look at 2x is less than 8. What would we normally do? We would normally divide by 2. So again, if there's a third side, we're just going to make sure that we divide that one by 2 as well. So we get negative 1 is less than or equal to x is less than 4. All right, as soon as x is alone in the middle, that means we've solved for it already. We just got to put in interval notation, which luckily we've already learned how to do. It's going to be from negative 1 to 4. X is sandwiched in the middle, so we shade in the middle. The negative 1 is going to have a bracket, because it has the line under it, has the or equal to. The 4 is going to have a parentheses. So it's going to be negative 1 to 4. All right, example 2 is going to be the same exact thing. Let's just see if we can do it without actually blacking out the side on the left, and see if we can just keep that in there and just remember to do it to all 3 sides. All right, so just looking at the middle, we have 2x minus 1. How do we get rid of a minus 1? We would add 1. So we're just going to add 1 to all 3 sides. So we get negative 10 is less than 2x is less than or equal to negative 4. All right, we have 2x in the middle. How would we get rid of 2? We would divide by it. So again, just do that on all 3 sides. So we got negative 5 is less than x is less than or equal to negative 2. All right, so if we put that on a graph, we got negative 5, negative 2. We shade in the middle with a parentheses on negative 5 and a bracket on negative 2. So our interval notation is going to be negative 5 with parentheses to negative 2 with a bracket. All right. Example 3. again, just like before, if we have a fraction, we can just clear it out with the LCD. We just multiply everything, every single term, by that LCD though. So 3 times negative 3 is negative 9. Less than or equal to, that one cancels out. We just left with x. And that'd be minus 15 is less than or equal to 3 times negative 1 is negative 3. Now, if we have x minus 15, all we'd have to do is add 15. And we're going to get 6 is less than or equal to x is less than or equal to 12. So we got 6 and 12. We shade in the middle. Both of them are going to have brackets this time because they're both or equal to. So we're going to have 6 to 12, both with brackets, as our answer. All right, last one. So again, if we look in the middle, first thing we'd want to get rid of is the 6. So we're going to subtract 6 from them all. So we get negative 16 is greater than negative 2x is greater than negative 26. Then we'd need to divide by negative 2 to get rid of that. Remember, we just divided by a negative, so all of our inequalities are going to flip. So we're going to have 8 is less than x is less than 13. Put this last one on a graph. So 8 to 13, shade in the middle, parentheses on both, and we get 8 to 13 as our answer. All right, sorry, I know this video went a little bit long, but hopefully that gives you an idea on how to solve inequalities, how to solve compound inequalities, and how to put stuff into interval notation. All right, with that said, I will see you in the next video. Bye, guys.